welcome to Enots Engineering. In this video we'll make the cams, the cam bosses, the camshaft, the locking screw and also finish off the table. The next job is to make the 3 cam bosses out of a 1 1/4 bar. Only 2 more to make. We now cut the 3 cam discs from the sheet steel supplied. I've changed the internal 3 jaws for external ones and placed the cam plate in the jaws. The first job to just mark the centre using the centre we've just drilled. We can scribe a line to give a diameter of 2 3/4 and also a line 3/4 from the centre to mark the position of the cam hole. We need to now centre drill on that line so that when we put this back in the lathe we'll have the position of the hole we need to bore. I'm drilling out the 2 screw holes so I can fit a larger screw. face off the wooden lock to give you a good surface to fit the plates to. Okay, I've screwed the cam plates to the wood, and off the first hole that we drilled, the centre location, I've put centre in there, and I'm supporting it with the centre on the back of it. Now if you turn the chuck round, you can see the run out. Just backing the side off, tighten that up. Because it's into wood, you can tighten it more as the jaw just sinks into the wood. That's running out of thou. The next job now is to move cam plates in the chuck. At the moment we set it up on the centre to machine the outside. Now we're going to move the centre to this position. Using the centre in the tailstock. So now I'm located on the bit of pressure to push it back onto the chuck. Now retighten the jaws. I'm a bit concerned about that one. Just check how many. Yeah, that's right on the edge, so I don't like that. So what I will do, I'll cut some of this wood off so that the chuck jaw can go down further. Okay, I've removed some of the wood, and as you can see now, I've got a lot more clearance. I finished the cam plates off by drilling and tapping the bosses and fitting the plates with 3mm cap heads. The next job is to mill a flat on the cam bar so that the grub screw in there will grip the bar without this turning. I did an end mill, 5mm end mill in the drilling machine. Just just want to spot the bar. This is the gear cutting chart for the Boxford lathe with a metric lead screw. To set a 1mm pitch, we set the idler gears as in figure 2, with an 80, a 72 and an 18 gear. And for the 1mm pitch we need a 40 and 30 tooth gear. To set up a 1mm screw thread on this Boxford lathe, I need to put a 30 tooth gear on the screw, the main screw, and a 40 tooth gear on the stud. Now in between those we've got a 72 to 18 and an 80, which if you look at the chart, that is figure 2 on the chart. The lead screw is 3mm pitch. This is the clamp nut that I want to put a 1mm pitch thread in. It's been drilled out to 9.1mm, so I have to now set the boring bar up with a thread cutting bit. This is what I've made. It's just a piece of bar machined down so it will fit in the hole, and then a hole drilled and tapped in the end with a cap head in. And then here you can see a 3mm tungsten carbide bar with the 60° point ground on it for the metric thread. I'll set my boring bar at centre height using the tailstock. Now I just want to make sure that it's square to the face of this nut. So using one of these thread gauges, I'm not actually using the gauge to set the tool, because it's so small, the tool is, it won't fit in any of these. It's too small for any of the V cutouts. So I'm just using the edge of the boring bar to the face. So if I get this square on the face of the nut and then square up the edge of the boring bar to that, I can lock that. I know that the boring bar is then square to the hole and the face. These are the details for cutting metric threads. Once the lock nuts are engaged, I can't disengage them as the lathe has no thread counter on it. So you put the cut on, go through the bush, back the tool off, reverse the lathe to bring the tool back out, and repeat that till you go to a depth of about 0.6mm. Right, I've just changed my setup. What I've done here is I put the driving plate on, which gives me a bolt here which will drive the job. Centre in each, the headstock and the tailstock. This is where I want to produce the thread on here to match the one we've just cut on the nut. So the way I'm holding it, just putting that in the centre there, in the centre on that end, so that I can take it out to try the nut on the thread, put it back in and be in exactly the same position every time. To set the tool square, because there's such a small cutting edge on the tool and the V's on this thread setting gauge are bigger, I've had to use the side of the tool, and I'm assuming that the manufacturers of this tool made the V square to the edge of the tool. So I'm using the side of the tool to line up on the tool and the front of the gauge to line up on the bar to know that my tool is square to the job. I've not set the compound slide at an angle, it's square because I'm only going in about 1/2 mil depth, so it's not a coarse thread, it's a very fine thread. I've set a slow speed so I can stop the tool before it hits the shoulder. Every time I'm going backwards, I'm removing the tool from the job, feeding it back in at the start, so each time you're giving a new cut. Because if you left the tool in and just reversed it, it will score another thread with the backlash in the gears in the opposite direction. This is a finished table. So here you have your tilt mechanism. I'm slackening the nut off this side and turning the handle there. You can tilt the table. I've just got a mark on the degrees there. You've got your sliding for your grinding your tool. You've got a stops so you can come to a stop, so if you've got a drill or an end milling you can stop before you go too far. You've also got a lock on there. I haven't made the screw yet. In the middle is a lock so you can fix the table. I'll turn it over. You can see the cams that work off the shaft. Unlock it and then the cams will bring the table up or down. I've just got to set those in the correct positions. Bearing bar there and the sliding bearing. In that hole there goes the tool holder, tool and cutter holder, and that's the next item we're going to start making.